welcome back guys. In this video we are going to study about wired local area networks. So as the name suggests, it's a local area network, which means that it is present locally and it is designed for limited geographical areas such as a building or campus, which means that it has been designed for small areas and it has limited reach. So in LAN there are many technologies that has been introduced, which are Ethernet, token ring, token bus, or ATM LAN. But these technologies, except Ethernet, have been survived for a while but then went away. But Ethernet is by far the dominant technology, so our main focus would be on this Ethernet. So to regulate things and keep things in control, there are some standards that has been introduced or set by Computer Society of IEEE, which are known as IEEE standards, or these are also known as IEEE Standard Project 802. So what are these standards? These standards are set for manufacturing and interconnectivity between LANs. And what else it do? It specifies the function for physical layer and data link layer. And one more thing that it does is that suppose it's a physical layer and this is a data link layer. So it has divided this data link layer into two sub layers that are logical link control, which is LLC, and media access control, which is MAC layer. So this is what Ethernet standards are. So I hope you understood the IEEE part. So now moving on, our next topic is frame and frame format. So what exactly are frames? So frames are, okay, so there is a network that we have created. The use of network is to send data. So data is sent in the form of packets, and what packets are called in Ethernet LAN is frame. So packets in Ethernet LAN is known as frame. So that is what frame is. So now for better understanding of it, let us first understand its format for the frame. So frame has 7 parts, as you can see in this diagram. The first is preamble. First one is preamble, then there is SFD, then there is DA, then there is SA, then length of type, then data and padding, and then CRC. We are going through each of them line wise. So the first one is preamble. So preamble it is of 7 bytes, and what it is a pattern of alternating zeros and ones. What it does, it is a 7 bytes and it creates a pattern using zeros and ones. So how it helps is that these patterns that it has created using zeros and ones, it forms a alert system. it forms a alert system. So what this alert system does is that it warns or it tells the receiving system that packet is coming. This is the only job of preamble, to tell or to warn the receiving system that the packet is coming and be ready for that. So, and one more important point is that the preamble is formally, officially, is not a part of frame. Actually, it's a part of physical layer. Okay, so after preamble, our next field is SFT, which stands for Start Frame Delimiter. So its size is of 1 byte and it signals the beginning of frame. It tells that the frame has begun, and its job is to warn the receiving system that it is the last chance for synchronization. So it means that it tells the system that it's the last chance that it can do the setup before the packet enters the system. Now after SFT, the next field is DA. So DA stands for destination address, and it is of 6 bytes. So as the name suggests, it's a destination address. It's a physical address of destination. Now same goes for SA, which is also of 6 bytes, and it stands for source address, and it is the address of sender who is sending the packet. Then the next field is our length or type. It basically defines the length of data field, which is this field. It basically defines the length of this field. Now next is data and padding. So data, this field contains data which has been encapsulated and have come from upper layer protocol. And it can be minimum of 46 bytes and maximum of 1500 bytes. Then our last field, which is CRC. So CRC it stands for cyclic redundancy check, and it contains error detection information. So this was the format for frame, and these were all the parts. Now the size of frame. So this frame can be minimum of 64 bytes and maximum it can go up to 1518 bytes. Just keep this in mind. So after learning about the frame formats, let us move on to the address. So each station that is present on Ethernet network such as our PC or printer or anything that is present on Ethernet network has its own NIC. So what NIC stands for is Network Interface Card. So it fits inside a station and it provides a 6-byte physical address to the station. This is the format of this address. It's a hexadecimal address with columns. It's a hexadecimal address with column. For example, this address 4A3010211018. This is a hexadecimal address with colon, and it is an example of Ethernet MAC address. One more thing, this NIC address is often called or referred as data link address or physical address or MAC address. So after learning about the addressing and its format, now let us move to the types of addressing. So as we all know that source address can be only unicast, which means that the packet can only come from one source. It can't come from multiple sources. But the destination address can be of different types, that is unicast, multicast and broadcast. So we will learn about these three things. So unicast, as the name suggests, that it is one-to-one relationship. That means source is also one and destination is also one. Then there is multicast, which is one-to-many relationship. That means that the source is one, the packet is coming from the one source, but it is going on to a specific group of networks. Then there is broadcast. It is nothing but a special case of multicast in which one packet is going to all the recipients that are present over the LAN network. So multicast was going to a specific group of network that we want to send to. But in broadcast, it is going on to all the stations or the networks that is present over the LAN. So how this address is differentiated? So in unicast, this LSB, which means the least significant bit, in case of unicast it is 0, this, and in case of multicast this is 1, and in case of broadcast all are 1. So this was all about the types of addressing. So after studying the addressing part, let us move on to the history of Ethernet. So Ethernet was created in 1976, and since after that it has gone under 4 generations, which you can see here. First one is standard, then there is fast Ethernet, then gigabit Ethernet, and then 10 gigabit. So the speed of each Ethernet has been increasing exponentially. So first one is standard Ethernet. It was the original Ethernet, and its data rate speed was just 10 Mbps. So as we all know that it is a history today, so why we are learning about this, so that we can get the better understanding about rest of the three Ethernets that were introduced after that. And this standard Ethernet used to work on a protocol known as CSMA-CD, which stands for Carrier Sense Multiple Access with Collision Detection. And it is a very important part of the standard Ethernet, so we are going to study in detail. So now we know that standard Ethernet works on a protocol of CSMA-CD. So before learning about this protocol, let us first understand the need of this protocol, that why we need it. So standard Ethernet, in these stations are connected via a star topology or bus topology. This is the star topology, where there is a one main station and all other things are connected to it. And this is the bus topology. So in this, what that means that there is a medium which is sending the packets or frames, and there are other stations which are getting it. So how it's happening is that there is a medium, suppose this medium is sending a packet, is sending a frame. So these all other mediums would get the frame, but only the real destination frame, the real destination. Suppose only this station needs the frame. So only this station will keep the frame and rest other stations will discard it. So this was the working of this standard Ethernet, that only one station that actually need that frame would keep it and rest other would discard it. So the problem arises that there was no mechanism or protocol to make sure that no two stations are using the same medium. So there was no protocol to define that. So there was no surety that how can we be so sure that there are no two mediums are using the same medium. So that is where CSMA CD protocol was introduced. Okay, so now we know that we don't want more than one station to access the same medium at the same time. So why don't we want that? Because if two or more stations are accessing the same medium at the same time, what may happen that frames can collide, which may result into lost or corrupted frame. Our data can be lost or corrupted. So what is the method to reduce that? So the method, we all know that it is CSMA-CD protocol. To follow CSMA-CD protocol. So what actually CSMA-CD protocol does is that the stations that are on the receiving end sense the medium. What that means is that it sense the state in which the medium is present. State means if the medium is idle or busy. So now we know that CSMA protocol wants the station to sense it, that whether the medium is busy or idle, to sense the state of the medium. So it is based on the principle of sense before transmitting. Or in layman term, we can say that it is based on the principle of listen before speak. But we need to know whether the state of the station before sending it, so that the collision would not happen. So after that, CSMA can only reduce collision. It can't just it can only reduce collision, it can't remove collision. So why, after applying the CSMA protocol also, why this collision is happening? Because of propagation delay. So what is propagation delay? So when the sender station sends a frame to the receiver station, okay, we know that it can happen to CSMA and no collision would happen. So in this also, when the frame is going to the receiver, the first bit of the frame will take time to go up to the receiver. It would be a very short amount of time, but it would get delayed. And the receiver station also would need some time to sense that the frame is coming. So that's why there might be a good chance of collision because of propagation delay. So now the moving on, second generation is the fast Ethernet. While standard Ethernet was just 10 Mbps, fast Ethernet is an upgrade to 100 Mbps data rate. It has almost same frame format as standard Ethernet was, and the main point is that it kept the MAC sublayer untouched. In standard Ethernet, it was using the MAC sublayer. In this, the MAC sublayer is untouched. So there are two methods that there are two access methods that the fast Ethernet use. The one is half duplex and the other one is full duplex. So in half duplex, what happens is that there is a hub which is shared among stations. So in this, there are chances for collision. So this uses the CSMA approach. While in full duplex mode, what happens is that there is a switch and computers or other switches are connected to it. So in switch, the data is stored. So the data is stored in the switch, and when the computer or the other switches wants them, the data gets transmitted. So there is a personal switch, so there are no chances for collision. Hence, it doesn't use CSMA approach. There is one more important feature that was added in fast Ethernet, that is auto negotiation. So what that means is that the medium negotiate the mode or the data rate of the operation. So how it helps is that it can connect to incompatible devices. For example, standard Ethernet has a data rate speed of 10 Mbps and the fast Ethernet has data rate speed of 100 Mbps. Via auto negotiation, they can negotiate the data rate speed and can get connected. So that was the fast Ethernet. Now the more upgraded version, the next version is gigabit. So it's the same as the fast Ethernet, just it is an upgrade to 1 Gbps. And it also access via full duplex or half duplex. This is same that full duplex uses switches and the mechanism is speed, and it uses half. Just one thing, that in this full duplex mode is more used and half duplex is rarely used. And it also supports auto negotiation. Now moving on to the fourth part, which is 10 gigabit. So in this, it's an upgrade to 10 Gbps. And it only operates on full duplex mode. So that was all about it. Thank you so much.